All right, let me tell you about something that's a bit like uncovering a secret code hidden in the fabric of our universe. Have you ever thought about what space-time really is? Most of us think about the 3 dimensions of space and 1 dimension of time, kind of like a stage where things happen. But what if that stage isn't just a backdrop? What if there's an entirely different way to build it? A way so revolutionary, it tosses out the idea of space-time being fundamental altogether? This, my friends, is where Twistor theory steps in. Twistor theory was born in the brilliant mind of Roger Penrose. You know, the guy who's also behind black hole singularities and mind-blowing ideas about quantum consciousness. He's a bit of a rock star in the physics world, and Twistor theory is one of his boldest creations. It's not some dusty, fringe idea either. It's been steering some of the latest thinking in quantum gravity and string theory. But here's the twist. Pun intended. Instead of working with space-time as chunks of coordinates, Twistor theory flips the question. Imagine space-time as we picture it. A giant grid of events. Doesn't really exist in the way we traditionally think. Twistor theory replaces it with something far more bizarre and elegant. A space of twistors. So, what's a twistor, right? Think of it as something more mathematical than physical, at least on the surface. A twistor is essentially a 4-dimensional object, but here's the kicker. It skips space-time entirely. Instead of being here or there, or happening now or later, twistors live in a world where the notions of space and time blur together. And this twistor space, this alternative realm, is designed to simplify the equations we use to describe the dance of particles and forces. Let's slow down here for a second. Does this seem abstract? Look at it this way. If space-time is like a fabric, with warp and weft representing space and time, Twistor theory isn't about the threads. It's about an entirely new loom altogether. Instead of weaving threads, it stitches connections between light rays and spins. Light rays. Twistors are closely tied to the paths of light itself. Think about a photon barreling through space. The seamless, perfect path it takes is something twistors latch onto, making sense of it without all the mathematical mess we often have to deal with. This obsession with light isn't accidental. It comes from Einstein's theory of relativity. Light truly operates at the universe's ultimate speed limit, right? So, twistors let us rewrite some of physics' toughest equations, using what are essentially shortcuts tied to light, rather than the usual x, y, z, and t coordinates. But how does this connect to our reality? Well, here's a good analogy for you. Let's say you're drawing a map, not a regular map, but a 3D map of the ocean floor. Normally, you'd chart points, lines, and surfaces. Twistor theory gives you an entirely new charting system, one that maps relationships directly, bypassing the space and time gridlock entirely. This approach has already shown practical results. Back in the mid-2000s, researchers found that twistors could supercharge calculations in particle physics. Usually, calculating how fundamental particles interact at places like CERN can blow up into ridiculously messy computations. Twistor methods? Way cleaner, way faster. It was like going from scribbling with crayons to having a laser etching machine, all thanks to Twistor's elegance. And for mathematicians? Well, Twistor theory feeds into deep geometry and the study of complex spaces. If you've heard of complex numbers, those weird numbers involving square roots of negative ones, twistors play in a similar sandbox, but with way more variables and symmetries. They're like mathematical chameleons, switching forms to match the underlying physics. One of the most exciting parts of Twistor theory is its potential to unite quantum mechanics and general relativity. These are 2 pillars of modern physics, yet they're like oil and water. They just don't mix. Quantum mechanics is all about probabilities, tiny particles, and uncertainty, while general relativity is the beautiful geometry of massive space-time and gravity. Twistor theory? It's hinted at ways to bridge this chasm. And here's something to blow your mind. Twistors don't just make the math easier. They reimagine what reality is made of. Light, spin, and relationship, not points on a space-time map. Here's where it gets even wilder. Some researchers think twistors might hint at a deeper, more fundamental structure beneath everything we know. Imagine peeling back the layers of our universe, only to find that what we thought were atoms and quarks are really intricate connections in a vast network of twistors. Is it all speculative? To some extent, yeah. Not every physicist is on board with twistor theory. Critics argue that it simplifies some areas while leaving others just as tangled. And to be fair, it's not a theory in the sense of making testable predictions on its own, at least not yet. But the breakthroughs it's already inspired in other fields suggest it's more than just a clever mathematical game. So why does this matter to you and me? It's not just about highbrow physics conferences or award-winning papers. Twistor theory is one of those ideas that remind us there's more than one way to see the universe. It challenges our intuition about how reality is structured, and that, honestly, is the real magic of science. Twistor theory might not give us flying cars or teleportation tomorrow, but it's reshaping the conceptual tools we use to explore everything from particle interactions to the origins of the cosmos. If you're still with me, I hope you're as blown away as I am about the possibilities here. Twistor theory doesn't just rebuild space-time, it reimagines it completely. What if our universe isn't defined by points and moments, but by light, spin, and the relationships binding them? Isn't that an idea worth exploring? So, don't forget to subscribe and hit that like button. Let me know in the comments. Does twistor theory spin your brain in the best way? Or do you think we're inventing solutions in search of a problem? And hey, the channel's still new, so every click and comment helps us dive even deeper into the universe's wildest secrets. I can't wait to hear what you think. Stay hyper-focused, and remember, the next revolution in physics might already be written in the light itself.